These are simple problems about heat. Heat, symbolized by Q, is equal to Cm delta T, where C is the specific heat capacity in units of calorie per gram degree Celsius. M is your mass in grams, and delta T is a change in temperature, which is final temperature minus initial temperature in degrees Celsius. For problem 33, we're asked to use the formula to show that 3,000 calories are required to raise the temperature of 300 grams of water from 20 degrees Celsius to 30 degrees Celsius. We're asked to use the specific heat capacity of 1 calorie per gram degree Celsius for water. So to solve this problem, we use the formula Q equals Cm delta T. Our substance is water, so specific heat is 1 calorie per gram degree Celsius, and we have a mass of 300 grams, and our temperature change is 30 degrees Celsius minus 20 degrees Celsius. When you multiply all those values, you end up with 3,000 calories, which is what's given for problem 33. We're asked to use the same formula for problem 34 and show that 12,570 joules are required to raise the temperature of the same mass, but this time in kilograms, of water through the same temperature interval. For the specific heat capacity, we use specific heat value C equals 4190 joules per kilogram degree Celsius. So we use the same equation, Q equals Cm delta T, but this time we use 4,190 joules per kilogram degree Celsius. We multiply it by our mass in kilograms, so you have zero point 0.3 kilograms, and the same temperature change, 30 degrees Celsius minus 20 degrees Celsius, and we'll end up with 12,570 joules. Since we're talking about the same material, 300 grams, zero point 0.3 kilograms are the same, and these values, 1 calorie per gram degree Celsius, is the same as 4190 joules per kilogram degree Celsius. We also have the same temperature change of 10 degrees Celsius. The value 3,000 calories is the same as 12,570 joules. For 35, we're asked to show that 3,000 calories is 12,570 joules. It's the same quantity of thermal energy in different units. So since every 1 calorie is equal to roughly 4.19 joules, we apply this conversion factor, 3,000 calories multiplied by 4.19 joules per calorie. So the unit calorie will cancel out, and we multiply 3,000 by 4.19 to end up with 12,570 joules. That's the only unit left here once you perform the multiplication. So it's correct to say that 3,000 calories is the same as 12,570 joules.